Ah, that was a dodgy grip. Okay, so back to what I was going to talk about. Isaac Newton's first law states that an object at rest tends to stay at rest, while an object in motion tends to stay in motion, unless an external force acts upon it. When a basketball player passes, yep, that's me, it would elucidate that there is nothing to obstruct the ball, despite a few other external forces act on the ball. If it wasn't for these forces, the ball would continue to travel in its current path. First, gravity acts on the ball to pull it down to Earth. Air also counteracts the ball in the form of drag, as you all know. While not noticeable indoors, wind can be a major factor during outdoor games. That's right, the wind can actually make the ball go another direction due to air resistance.
Okay, so I know to block Ironman's shot, I can use Newton's second law, which is F equals ma. So, I know he was close to the 3-point line, which means he was probably travelling at a speed of 18 miles per hour. So 18 miles per hour to kilometers per hour would probably be 1 meters per second squared. Okay. So now that we know that, we can figure out how much force we need to apply to block that shot. So the mass of a basketball is around 600 grams. So F equals the amount of mass, which would be 100 times 8.1. So that means, since mass is in kilograms, we convert that to 0.6 kilograms, which is 600 grams, times 8.1. Therefore, the amount of force would equal 4.86 newtons. So, to block Ironman's shot, I need 4.86 newtons.
As you can see here, Newton's third law was intact during this play. Newton's third law states that for every action there is an equal and opposite reaction. With basketball, when shooting, your hand exerts its force onto the ball.
The opposite reaction is that the ball will exert its own force onto your hand. The force is actually the pull of gravity. Gravity is pulling the ball towards the center of the earth, hence the opposite reaction.
The spin or the Magnus effect on a shot in basketball can be the difference between nothing or another 2 points. The spin of the shot doesn't really make a difference if we're talking about swish shots here, but it will significantly assist you with bank shots and rim shots. This is most likely because once the ball hits the back of the rim or the backboard, the velocity of the ball changes. Backspin or the Magnus effect on the ball will allow the ball to spin back from the board into the hoop, as seen here. A ball without backspin will most likely bounce off of the backboard and have a smaller chance of going in. This relates to physics, as the backspin on the ball or the Magnus effect changes the direction of the ball so that it is moving vertically. Also, when spun, the basketball hits the board, it will also change the velocity and the speed in which it is going at. The Magnus effect is also used professionally because it makes sure that the ball keeps on going straight, whereas if you threw it without any spin, it will change direction slightly due to air resistance or just general misplacement.